Hello students, I am Dr. Saliha Jamal, Associate Professor from the Department of Geography, Aligarh Muslim University, Aligarh. Welcome you all to the today's class. So today we are continuing with the previous class in which we have started the application of spatial analysis. In previous class we have discussed the application of spatial analysis that is generalized application where it is generally used. If we talk about its application, generally there is a wrong notion that spatial analysis is just the mapping the physical objects, or we can say the spatial objects. But I can say here that it is even more than that, because we know that the spatial informations are generally acquired from the different sources, maybe from the remote sensing imageries, maybe from the aerial photographs, from the ground surveys, I can say, from the GPS, even from the observations. We can collect lots of spatial information, but the decision makers can integrate all these versions which are acquired generally from the different sources and can get and can have a very smart decision accordingly whatever we need. For example, regarding its application, we can say that spatial analysis is generally what we have discussed previously in the class, that it is generally used in the traffic management in the urban settings, I can say, which allows the authorities, or we can say the to take a proper step to see the if somewhere congestion is taking place or some sort of traffic jam is taking place, and take suitable decision to make the cities more resilient. Similarly, spatial analysis also allows us to check on various geographic progressions, diseases, their spreads, we can say the diffusion of the diseases, and accordingly the efforts to control its spread can be taken. Even the government bodies also can use spatial analysis and its related techniques to map the vaccination strategies in a particular spatial area during the deadly pandemic, whatever earlier we have seen in COVID-19. So if we think and realize that in today's in this modern world, in one way or the other we are using this spatial analysis in a very effective way in our day-to-day life. For example, if we want to book the cab on the app, or even we can book the meals for us, even we can track the deliveries of the meals, we can access GPS in order to know the fastest route, or we can say traffic free routes to travel from one place to another. So overall we can say spatial analysis is now observed as a universal one of the universal need, and we are using it in our day-to-day life. And these spatial analysis related techniques have made our life a bit very much easier. Although if I can say the spatial information were existing as from the information from the satellite imagery, aerial photographs were existing from the long time, but filtering those voluminous information in such a way that that should be in usable form and we get usable information from that voluminous information has been quite a big task. So we are dealing with that through the spatial analysis. So these things just I have reviewed what we have discussed in the previous class during the application of spatial analysis. What is special about this class? Here we are going to discuss the application of spatial analysis in different disciplines, whether it may be biosciences, economics, it may be in certain, we can say, sociology, education sector and all. So in today's lecture includes the application of spatial analysis, particularly in economics, I can say. You can see here on the slide, and where we will be discussing the spatial econometric location theory, regional development, and application of spatial analysis in biosciences. So these two will be discussing in this particular class. Coming to the application of spatial analysis in economics, When we talk about its application in economics, it involves various aspects. The aspects we can say in terms of the relationships between the spatial data, the dependency of one spatial information on the other spatial feature we can say, or we can say a sort of patterns exist in the spatial phenomena, related economic phenomena. So, these are things we generally deal with the spatial in spatial analysis in economics. Coming to the first specific use here, I would like to discuss. It is mainly used in spatial econometrics. How? It involves the analysis how various economic variables are generally influenced by the different spatial factors, such as we can analyze proximity to markets, proximity to different natural resources, or various other features. So, we can also assess. So, this particular field, the use of spatial analysis in econometrics generally includes various statistical technique also to account for spatial dependencies and patterns in data, and which allows the researchers to stand better the relationship between the economic phenomena and the spatial factors. So, overall we generally see when we analyze this spatial phenomena, we see whether a set of pattern in certain economic phenomena is existing, or even the set of different trends, something anomaly in the spatial information is existing. Some sort of trends could be found in particular spatial economic phenomena. So, these things generally we deal with in spatial econometrics. Again, I would like to explain by taking another example. For example, in locational aspect, how in economics, in locational aspects, it is utilized. If we revise, if we remember the aspects of locational theory, that is finding out the ideal location for the establishment of certain business, or in for the finding out the ideal location for certain industries, factories, or various services, we can say amenities and facilities, that where it should be functioning in a very better way, more efficiently, minimizing certain, I can say, transportation cost, maximizing the benefits, that will give the ideal location. So, here also in this location aspect, the spatial analysis provides in finding out the optimal location for various economic activities, maybe the business, maybe the factories, maybe the various infrastructures, etc. This analysis, we can say, it generally relies on the spatial data and various analysis techniques to find out the locations that maximizes efficiency and minimizes the cost, or even achieve the other specified objectives whatever we need. So, these locational aspects are generally drawn on various principles from the economics, that may be borrowed from the geography, that may be borrowed from the operation research, in order to make certain informed decision regarding the spatial allocation of the resources. So, for example, suppose if someone likes to locate the iron and steel industry and want to find its ideal location. So, by having the spatial data or spatial information, what are the requirements of iron and steel industry? For example, iron ore will be the requirement. So, iron and steel industry should be located near the iron ore resource, and there are requirement is coal. So, if possible coal is available where there we can locate. If both is available, then it would be it will generate more efficiency and more profit. What is the networking, what is the accessibility, what is the road network for the transportation of the finished outputs. So, all this, what is the power supply, from where the power supply. So, by assessing all these aspects, we can get the specific ideal location for the particulars, or this can be easily that can be found out through the spatial analysis. So, this is one of the most important function where the spatial analysis plays its role. Again, if we see in economics, I would like to discuss here with the another example, like in regional development, use of spatial analysis in regional development. We know the lots of regional disparities are existing, whether we talk about the disparity of natural resources, where we talk about the allocation of the resources, whether we talking about the development aspect, some regions are overdeveloped, some are developed, some regions are even disadvantaged region, backward region, some are having the better facilities and amenities, others are lacking the amenities. So, in order to assess all these things, like mainly in regional development, spatial analysis involves assessing various I can say different disparities in economic activities, maybe the social growth or development across the different areas. But because whenever we talk about now the regional development, previous there was a notion that the regional development means we are talking about only the economic development. But with time it is felt a region can be fully developed if it's achieved the integrated development. Integrated development means whether the region should be developed economically also, it should be developed socially and culturally also. So, if we have to develop a region as a whole, we have to analyze all these aspects. So, here also spatial analysis generally assess the disparities in economics also, social growth also, etc. of a particular it examines the various factors that contribute to the regional disparities, such as maybe the differences in the infrastructure, maybe the differences in the human capital, or we can say the natural allocation of their resources, or even we can see in terms of policies and planning. So, regional development strategies generally aim to promote a balanced and sustainable growth by addressing these inequalities and leveraging the regional strength. So, basically overall it can be said that spatial econometrics, what we are talking about, the application of spatial analysis, the spatial econometrics focuses on analyzing all the spatial aspects of the economic variables, maybe in terms of the locational aspect, which involves identification of the ideal locations for the economic activities, and maybe in terms of the regional development that addresses the disparities in economic growth, and maybe the development of all over spaces, because all these things are interconnected with each other. So, this field is, we can say, interconnected, and these things whatever we talked about, locational aspect, we talked about the regional development, these are all, we can say, they complement each other, and through the spatial analysis we can have better and smart decision making process. Now, students, here also I would like to discuss some of the tools of the spatial analysis that can perform these functions. The functions means whatever we talked about in terms of, if we see here, let me come to that slide, the tools we are talking about. The tools, just to make you aware, there's these tools, just here I am discussing these tools because in fact I can say that introducing these tools before you, just to make you aware that whatever we talked about, these can be performed through these functions. So, there are several spatial analysis tools that can employ in the field of the econometrics, in the field of the location aspect, in the field of the regional aspect. I would like to name them, that these are the tools that are existing and through which we can perform the certain functions, like through the geographic information system, GIS. This is a software which allows for the visualization of the spatial data. It also allows for the manipulation and modification of the spatial data, and also it analyzes all the spatial information. So, everything is possible in GIS environment. We can have lots of data together, we can have lots of data acquired from the different sources, particularly in the same environment. We can normalize the data, we can find out the subsets of the data, and even we can manipulate also the data according to the need for further analysis. So, GIS environment generally provides the various capabilities, I can say, for mapping, and by mapping we can get the information from the map at a glance, lots of information from at a glance. Similarly, it also allows the researchers to have the spatial querying. It allows the overlay analysis where we can superimpose, we can overlay different layer of maps of different spatial phenomena to get to fulfill the objectives of what we actually need. It also includes various spatial statistics, etc. So GIS environment have lots of functions through which we can solve the problems of the locational aspect, regional development, etc. Similarly, another tool, that is the spatial regression models, that is also very important. These spatial econometrics, if we talk about, that generally utilizes various regression models that account for spatial dependencies among the observations what we are having. For example, these models includes various spatial, I can say, auto-regressive models, various error models, we can say spatial lag models, etc. I would like to name some of them, the software packages which can be used to solve these functions. For example, Geoda, R, Python, etc., which can be used for such types of functions. Not only this, in economics we can have the network analysis also. When we talk about the network analysis, the first thing comes in our mind that the transportation networking, we are talking about the road networks. Even we can have the network analysis for the social networks, or even we can have it for knowing the supply chains of any spatial unit. So these tools help us to identify the optimal routes, or we can say the shortest route, or traffic free routes, or even we can assess the accessibility, and we can analyze also the network connectivity. So we can do a lot from the network analysis. Again, I would like to name some software packages like ArcGIS network and analysis, QGIS, Network X. These are the, we can say, actually the Python library it is. These are the commonly used network analysis softwares. So another I would like to name it here, that is the spatial interpolation techniques. About the interpolation, I have already talked in my previous lecture. If you remember, students, simply interpolation is what? That is finding out the unknown values of the unsampled location with the help of the known values which is existing nearby or through the sampled location, in order to maintain continuity in data. Because many of the data generally we get that are not continuous in nature. For example, if you are talking about the climate data, sometimes by retrieving the climate data, we see certain intermittent data are missing generally. So in order to have it continuous data, we use this spatial interpolation techniques. For example, in temperature data we can use it, in precipitation data we can use this. Not only this, in digital elevation models we can use it. So these actually spatial interpolation techniques methods employ, and it estimates values at, we can say, overall from the unsampled location based on observed data points, or we can say based on the known points. So these techniques are useful for creating the continuous surfaces from the discrete means broken spatial data. So we are here, actually we are producing continuous surfaces or continuous data from the broken data or discrete data, and there are various methods of interpolation. The most commonly, if you remember, I have talked about, that is the IDW, that is inverse distance weighing method, most commonly used. Kriging method is also used. There are several other methods. So another tool I would like to talk about, that is the location allocation modeling. That is the location allocation modeling. This model generally it is used in location theory. Location theory means identifying the ideal location for certain economic activities in terms of the facilities, amenities, in terms of the location of the industries, etc. Actually, these models consider the factors like where the demand is existing, where the supply is needed. We can also assess the transportation cost with respect to the distance and the service coverage in order to identify the location that may optimize various objectives. Maybe the objectives in terms of I can say minimizing the transportation cost, maximizing the accessibility, maximizing the profit. So these objectives can be fulfilled through finding out the ideal location. So these location allocation modeling is particularly for that function. Again, I would like to name some softwares here. GIS software has a very good environment for this types of function. Optimization software like Cplex I can name here, that is also having very good environment to perform this type of function. Lastly, for this I would like to take one more name, that is the spatial clustering techniques. Clustering is what? Finding out the nodes, finding out something in nucleated. Here we are talking in terms of the economics, economy. So we are mainly related with the economic activities, economic phenomena. So spatial clustering methods generally identifies here the various spatial patterns or grouping of we can say data sets, maybe in terms of the proximity or similarity of the criteria in a particular spatial unit. So these techniques are useful to identify generally the clusters of various economic activity. It may find out the hotspots. For example, industrial hubs it can find out, that will be regarded as the hotspots for the industries we can say, and even it can find out the spatial disparities in terms of the economic activities. So again I would like to use here where various spatial clustering algorithms are generally used, and I would like to name the software packages like Python, R, GIS software. All these softwares can perform this type of functions in their environment. So I have introduced these tools, I have named these packages, students, just to make you aware that these packages or these softwares have the functions for where we can have the application of spatial analysis in the economics discipline, like in terms of locational aspect if we are functioning, or in terms of the regional development if we are functioning. So coming to the next discipline, the application of spatial science, here I would like to discuss with respect to the biosciences. Biosciences actually it includes all the things related to the different we can say ecosystems, life we can say, or biomedicines, etc. All these things are included under the biosciences, or overall we can say it is broadly divided into biological aspect, which deals with the life of the organism, its habitats, ecosystem and interaction, or landscape ecology, or I can say it deals with the biomedicines, we can say life of the human beings, organs, or even we can say the different cells, or even the spread of diseases, their origin, all this we can say through the biological diseases. These all things come under the biomedicine. So what is the application of spatial analysis in biosciences? So starting with the landscape ecology, this field actually focuses on understanding how the spatial arrangement of different habitats in ecosystem is influencing the ecological processes and patterns in a certain spatial unit. Here the spatial analysis can examine the landscape patterns at various scales, and researchers can gain various new information into the biodiversity distribution. What type of biodiversity distribution is having in a particular spatial unit can be analyzed, species interactions can be analyzed, and ecosystem functioning of a particular place can also be analyzed. For example, we might study how the fragmentation of habitats affects the species movement and the population dynamics. If we have found the certain habitats in fragmented form, so how this is affecting the species movement in these fragmentation, and what are the population dynamics in different fragments can be seen. This can be analyzed through the spatial analysis, and even how the configuration of the landscape is influencing the spread of invasive, means exotic species, that also can be analyzed. So this is the thing how we can use the spatial analysis in landscape ecology. Not only this, but if you see in biomedical science, related to the biomedicine itself only, how the spatial analysis is useful. It is very much useful nowadays in disease mapping. Not nowadays, but disease mapping through the spatial phenomena, through spatial mapping. It is a long ago ancient process that was also represented in a very specular way by the John Snow. Disease mapping nowadays has become a very important task through the spatial analysis, which involves analyzing the spatial distribution of diseases, origin of diseases, diffusion of the diseases, spread of the diseases. Everything can be analyzed. Finding out the risk factors of the diseases, everything can be analyzed through the spatial analysis. By mapping the occurrence of the diseases, such as for example the malaria, dengue, or even we can say encephalitis, or even the COVID-19, we can identify the hotspots of the infection, and why the certain spatial unit is behaving as a hotspot of a certain disease. We can find out the underlying factors which is contributing and making the particular spatial unit as a hotspots. So accordingly, the various targeted way planning can be done. So we can understand the clusters of the disease, the hotspots of the disease, and the underlying factors driving this disease transformation, all can be analyzed. So this information is very much important for the public efforts, we can say, for the public health efforts, we can say, and it allows a very targeted interventions, such as it can be used in vaccination campaigns, in vector control measures, or even in the public awareness campaigns. So it is one of the very important I can say field where the spatial analysis is used. Similarly, the conservation planning. Conservation planning, when we are talking now, because we are talking about the protection, conservation, sustainable development of the resources, etc. We know conservation, that now it is the need of the hour. If we see in past, the population was handful, resources were abundant, so there was no impact. The resources replacement rate of the resources was that much that we are not very much concerned with that. But with time, in the race of economic development, we have exploited the resources recklessly, and now due to the population pressure, we are exploiting the resources recklessly. But now it is a need of the hour. We have to conserve the resources for the sustainable development, so the our future generation can enjoy all those resources what we are enjoying now. So these conservation plannings particularly aims to protect and sustainably manage the biodiversity and the ecosystem. So here the spatial analysis plays a very important role, I can say here, in the process, very important role, and mainly it is used by the conservation planners to where they use various spatial data, including the map of the species distribution, their habitat types, their land use pattern, and even they can find out the vulnerable zone and where the priority of planning is needed. They can find the spatial unit, the zone having the high biodiversity value. they can find the hotspots of the biodiversity, what are the contributing factors for the hotspots of the biodiversity. Even the planners can find out the unique ecosystem or even the critical habitats of the endangered species. So these if they are considering these all things such as habitat connectivity, ecological corridors, landscape resilience and all, with all this spatial phenomena, then we the planners and the policy makers can have lots of insights and lots of information through the spatial analysis. So overall we can say that these things, the integration of landscape ecology, what we have discussed earlier now, disease mapping and conservation of planning is very much important for the holistic ecosystem management and the biodiversity conservation. So by understanding how the spatial pattern influences ecological process and disease dynamics, conservation practitioners can develop more effective strategies to protect ecosystem and mitigate the spread of the diseases and may promote sustainable development. So again, earlier how we have discussed the tools that can perform the above functions, here also I would like to discuss some of the tools that can perform the functions whatever we talked about in biosciences. Here I would like to mention the ArcGIS tool, which is very much important, and it has such environment where we can perform n number of functions, which is useful in having mapping the landscape ecology. We can have the disease mapping function also, and we can have lots of function for conservation planning. For example, here I would like to say the GIS environment, particularly ArcGIS, it has an environment like overlay analysis, in which users are generally allowed to overlay multiple layers of spatial data in order to analyze the spatial relationship. For example, in landscape ecology, we can have the layers, one layer of distribution of a particular species and another layer of their habitats, their configuration of the habitats or fragmentation of the particular species. Then we can have the land use, land cover pattern, we can have the map of certain ecosystem one upon the other, and accordingly we can extract the information whatever it is required in order to identify, in order to get the various information. So overlay analysis is a very important function that is existing that exists in ArcGIS. Even the proximity analysis is also one of the very important function that can be used in ArcGIS, which actually provides the tool for calculating the distances and the proximity between the various spatial features and the phenomena. For example, in disease mapping, the researchers can use proximity analysis in order to assess the spatial relationship between the disease cases and potential environmental risk factors. So accordingly, the certain risk factors can be contained through this. Not only this, in ArcGIS, the researchers also use the spatial statistics function, which offers n number of spatial statistical tools for analyzing the patterns and trends which generally exist in spatial data. And these tools can be used to assess spatial autocorrelations. They may be used for finding out the hotspot analysis or even for model spatial relationship between the variables, etc. For this tool, spatial statistics can use. So after quoting the ArcGIS, here another tool that is very much important, QGIS. We know that is an open source software, so it can be used for everyone, students. If you also want to use, you can use it. So QGIS also has a number of functions that can be used in biosciences, in landscape ecology, in disease mapping or conservation planning. For example, it has a very important tool of geoprocessing in QGIS. So it offers a wide range of, we can say, geoprocessing tools and manipulation of the spatial information, where the researchers can use these tools in order to clip out the information needed in order to merge if we want to have certain type of manipulated data, and even we can dissolve spatial features also. Similarly, the QGIS have the function of interpolation also. We have discussed earlier, that is for estimating the values at unsampled location based on nearby observation. This is simply the interpolation, and this is very much useful in landscape ecology for creating the continuous surfaces of environmental variables such as temperature. We can take the example of precipitation, etc. Similarly, in QGIS we can have the visualization tool which offers a very powerful visualization capabilities, where we can create maps and we can visualize spatial pattern and can get the information in seconds at a glance only. We can customize various symbology while mapping. Even we can create the map layouts, or even we can generate the publication quality maps for the PowerPoint presentation, for the presentation of reports, etc. So it is having a very strong visualization capabilities. So we can have ArcGIS, QGIS, and even we can have the R software with various we can say packages, spatial packages like spatial data handling packages that mainly it is used by the researchers to read the spatial data sets in order to perform various geometric operations. In our spatial packages, geostatistical analysis can be also be very helpful, and spatial visualization is also available in this R with the spatial packages, where we can have we can make the interactive web maps, and we can have the spatial data plots also. So, and lastly, the GRASS GIS. We would like to GRASS GIS. This is all the open sources. We have talked about QGIS, GRASS GIS. ArcGIS is not a open source. So GRASS GIS also have certain functions like the image processing function, which is very much important, one of the function which offers the capabilities for analyzing the remote sensing imagery, and where we can use this tool to classify the land cover of a particular place, and even we can detect the changes in land cover with the time, and we can extract various environmental variables from the satellite data according to our needs. So image processing function is very much important in analyzing the spatial phenomena, spatial data. We can have in GRASS GIS, we can have the terrain analysis also, and this is very much useful in characterizing the topographic features, and it is also, I can say, useful in assessing the landscape ruggedness, whether it is rugged landscape or non-rugged. A few of the tools like Geoda also have the various functions. Geoda can have the exploratory spatial data analysis, which is mainly known as ESDA, which is used to identify the spatial clustering at certain places, maybe in terms of the ecological or epidemiological data sets. The clustering can be identified. Not only this, Geoda has the function of spatial regression also, where it allows the researchers to find out the spatial autocorrelations among the different variables, among the different phenomena. It can have regression analysis functions, and it can also assess the spatial relationships which is existing in the particular spatial units. So, the content what I have discussed now in this class, students, I have discussed the application of spatial analysis in economics. I have discussed the that is application of spatial analysis in biosciences. Not only that, I have also talked about the different tools through which these functions can be performed, and this is just to make you aware that in spatial analysis, with the help of n number of softwares and n number of GIS environments, we have different tools to perform all the functions, where the application analysis can be seen in different disciplines like in economics or like in biosciences. Not only this, as the time is not permitting, we are going to continue this lecture in the forthcoming lecture also. Till then, have a good day. Student, thank you.